In this video, I'll be working through the question you see on the screen from the Pure Maths paper 3, specifically paper 3.2 from Cambridge A-level exams from 2023. I'll be doing all this on the board. Hopefully it'll be a lot like you're used to your teacher doing in a classroom. If you want other questions from this paper, you should be able to find it in a playlist in the description below. And if you find any of my videos useful, I'd greatly appreciate liking, subscribing, or even sharing it to a friend sitting the exams this year or next. In question 2, we have to solve the logarithmic equation that I've written up here on the board. It's actually not that hard of a question. It just has a couple of tricks to it, and you do need to remember all your logarithmic rules. So let me first say, when you're dealing with any logarithmic equation like this, or well, most of the time, there's never usually rules that are all the time. Most of the time, what you're looking for is to get this equation to look something like natural log something, let's just go x, is equal to natural log like something. Because then what you're able to do is you're able to just cancel these natural logs. Now you're not really cancelling the natural logs, you're actually putting e to the power of both sides. So you're putting e to the power of both sides like that, and it's the e and the natural log that cancel each other, leaving you, in this case, x equals 4. It's not the answer here, but that's roughly what we're trying to do. We're trying to get natural log everything on the left equals natural log everything on the right. Here we have natural log everything on the left, that's all good, but we have a mess on the right, so we can't just cancel these natural logs. So it's the right side, we need to get it to look like natural log something. And then we can just cancel these two natural logs. So that's where we start thinking about our rules for natural logs. Something multiplying a log, well, that's the same as the log, the number out in front here, multiplying out front, it would be the same if it's the power of it here. I'm not going to prove all these. These are the ones you're expected to just remember. All I'll say is practice makes perfect on these. Once you do a few hundred of these, you will remember. And then that's minus natural log 2. Now the next rule we sort of want to remember about natural logs are, when a natural log of something adds or takes away to another one, they can be combined. When it adds, it combines to multiply, and when it takes away, it combines to divide. I'll show you what I mean here. These is the same as natural log this guy, because he's a positive, there's a plus here, and divided by this guy because he's a negative. And now we have what we were looking for. Natural log everything on the left equals natural log everything on the right. The natural logs just get destroyed, just like over here. And we're left with 2x squared minus 3 is equal to x squared over 2. Multiply both sides by 2, we'll get 4x squared minus 3 is equal to x squared. Take x squared from both sides, we get 3x squared. Oh, sorry, I missed the multiply by 2 there. 2 multiplied by that and 2 multiplied by that. 3x squared minus 6 equals 0. We can take 3 out of both of these. X squared minus 2 equals 0. Let's just do that over here. Divide both sides by 3. 0 divided by 3 is 0. So we're left with x squared minus 2 equals 0. That gives us x squared equals 2. Now usually the next step would be x is equal square root of 2 plus or minus. Now, and that's fine, that's what we should do here. But at this point we need to be careful. When you're dealing with logs, you have to be very careful what you put into them. So let me draw what a natural log looks like over here. There's the graph of natural log of x. It never deals with minus numbers. In fact, you can try and put a minus number in a log. Log of minus 4. Log of minus 4. It will give you an error. You cannot put minus numbers into a log. So there's two ways to deal with getting this answer. First, I'll give you the simple way and the way you probably should do here. Any answer you get in a natural log question, I want you to test all of these answers. I want you to write this equation again. Write this side, put it in a calculator, see what you get. And this will be okay with both of these numbers. And then I want you to put this side in a calculator with both of these numbers. And it will be okay with plus square root 2, but your calculator will not let you do this side with minus square root of 2. And hopefully you can see why. Natural log of minus square root of 2. Minus square root of 2 is somewhere here. Natural logs cannot deal with it. So the examiner will take a mark away for this answer. You are expected to write, not 3. You're expected to write square root 2 with only a plus. You need to get rid of that minus. You can rub it out, I would advise you just writing a new line like that. You can give them the reason, because natural log minus 2 doesn't exist. Natural log minus square root 2, doesn't exist. Anyway, that's the full marks for this question. There is a slightly more difficult way you could have done this last bit, which you might have to do sometimes. You might have to decide when is x, so what numbers for x are okay. And to do that, we'd have to go back to the start and take all of our natural logs. For example, this guy here tells me x needs to be bigger than 0. That's why I was able to throw out the minus. And that works for this, but sometimes it won't. Sometimes might need to know what this guy tells us. And this guy tells us 2x squared minus 3 needs to be bigger than 0. You don't have to in this case, we could just put these in, but sometimes you might have to solve this to decide what numbers for x are okay. And solving this gets x squared is bigger than, let's see, 3 over 2. That means x is bigger than square root of 3 over 2, or x is less than minus square root of 3 over 2. So yeah, you don't have to go to this level in this case, and also these then combine, these two and this one combine, and that means the overall decider is x has to be bigger than the square root of 3 over 2, which I don't know what that is. Put that in a calculator, 1.2 or something, and this is 1.7 or something. Again, that's a bit more complex. You don't have to do that in this case. And in most cases, it is enough just to test the answers you get. I hope I didn't confuse you too much by that extra thing. It might come up in an exam. It might come up that you have to decide when is x. What numbers for x does this equation work? And it would be something like that. And again, this also. So all three of them combined, that only this one matters. Okay, I hope that answered question 2. For you. If you have any follow-up questions, please put them in the comments below. I'll do my best to get back to you. Thanks for watching. Have a good day.